right? The next question says, if negative 3, 5, comma, y is on the unit circle, find y. Again, somewhere you learned, if a point is on an equation, then you should be able to substitute it in and solve whatever unknown value it is. So what we're going to do here is we're going to sub into our unit circle equation. So, negative 3 over 5 squared plus y squared equals 1. Does everybody see where I got this from? Okay, so what's negative 3 over 5 squared? It would not be negative 9 over 10. Try again. It would be positive 9 over 25 plus y squared equals 1. So what is y squared equal to? What's 1 subtract 9 over 25? I'm sorry? Yes, 16 over 25. So what is y equal to? 4 over 5, just 4 over 5? Technically it would be plus or minus 4 over 5, right? Why would it be plus or minus 4 over 5? If this is negative 3 over 5, how do I know if it's in the third quadrant or the fourth quadrant? Do you see that? Yes? And you should know when you square root a square, it's both, right? I can substitute negative 4 over 5 and square it and get positive 16 over 25, right? Same with positive 4 over 5, I can square it and get 16 over 25. So when we have a 45-degree angle and I make a reference triangle here, and this is some x and this is some y and this is some point x comma y, the only thing I do know is this radius is 1. Actually, I know something else. If this is 45 and this is 90, what's the third angle going to be? 45 degrees. And what kind of triangle is this? At 45, 45, 90. What kind of triangle is that? An isosceles, which means this is the same length as that. So that means if this is x, y is also x. So I can use now Pythagorean Theorem to solve what x is. X squared plus x squared equals 1 squared. Does everybody know where I'm getting this from? So 2x squared equals 1, x squared equals 1/2, and x equals plus or minus the square root of 1/2, which is, in the first quadrant, I can reject the negative. Does everyone understand that? Why can I reject the negative? Because everything's positive in the first quadrant. And how do I simplify the square root of 1 over 2? 1 over root 2. And what's the same thing as 1 over root 2 if I rationalize the denominator? Root 2 over 2, I'll just show my step here. Okay, so that means x is root 2 over 2, which means y is also root 2 over 2. Which means this coordinate is root 2 over 2 root 2 over 2. So that is the exact value on the unit circle that you learned. So if we go to our unit circle now, and I like doing the families in color. So I'm going to do the 45s in blue here. So I just figured out that P of 45, leave some space below it, please. P of 45 is the coordinate root 2 over 2, comma, root 2 over 2. What's the related angle in the second quadrant in degrees? So 180 minus 45 is what? 135? So that, how would that change my coordinate? Yeah, it would make your x negative, so negative root 2 over 2, comma, root 2 over 2. What's the related angle in the third quadrant? 45 plus 180, what is that? 225 degrees. So how would that affect my coordinate? Negative root 2 over 2, comma, negative root 2 over 2, yes? Okay, what is the related angle in the fourth quadrant? 315 degrees. And how would that affect my coordinate? The y is negative, very good. Root 2 over 2, comma, negative root 2 over 2. Okay, we're going to leave our unit circle and we're going to go to the next triangle that you learned. And that was a 30, 60, 90 triangle. If I make a reference triangle here, this is my x, this is my y, my radius is 1. Does everybody see that that's the same triangle here? It's just a rotated triangle. If this is 30 and this is 90, that means this is 60. Yes? If this is 60 and this is 90, this is a 30. It's the same triangle, just kind of shifted and rotated. Okay, so in order to do this, again, my radius is 1. What I do here is I actually make a secondary triangle that's exactly the mirror image. If it's the mirror image, that means this is 60 and this is 30. And what kind of triangle do I make here then as a result? An equilateral triangle. Does everybody see this as a 60, 60, 60 triangle then? So if the radius is 1, that means all the sides are 1. But 2 seconds ago, this triangle was cut in half. So what does that make this little side right here? 0.5 or 1/2, 1/2, yes? So now that I know the side that's right next to the 60-degree angle is 1/2, doesn't matter which triangle I use, I can say that this is 1/2, and I don't know what x is, but I can put it into Pythagorean Theorem, and I get x squared plus 1/2 in bracket squared equals 1 squared. So I get x squared plus 1/4 equals 1, and what do I get when I subtract 1/4 from 1? I get 3/4. What do I get when I square root it? Plus or minus the square root of 3/4. I can reject the negative y. It's in the first quadrant. I can simplify this to be the square root of 3 over, what's the square root of 4? 2. Which means this length right here is root 3 over 2, which means this coordinate is root 3 over 2, comma, 1/2. Yes? To the 30 triangle. So let's go back to the 30 triangle. I'm going to use a different color. Let's use red. Yes, root 3 over 2, comma, 1/2. What's the 30 in the other quadrant? 50. Coordinate over here. Only the y would be negative. And what is that related angle? 330 degrees. So that would be root 3 over 2, comma, negative 1/2. Okay, going back to the other triangle, the 60 triangle. Let's just look at this for a second. If these are the same triangles here, and the length opposite the 60-degree angle was root 3 over 2, to this triangle over here, do you see that this is my length? That's root 3 over 2. And the one that's opposite the 30 over here is 1/2. So what's my coordinate this time? 1/2, comma, root 3 over 2. It's just the same switched, yes? Okay, let's go back. We're going to do the 60s. I'm going to do it in green. And what did I say 60 was again? 1/2 root 3 over 2. So what would the 60 be in the second quadrant? Yeah, so it's 120 degrees, and it would be -1/2 comma root 3 over 2. 300 degrees. And then 1/2 comma negative root 3 over 2. I'm going to change my color to purple now, and I'm going to do these. These are triangle necessary. You can read what the coordinates are. What's that coordinate right there? And that's at 0 degrees, yes? Okay. I'll just wing it. So we started and did the entire degrees here. Now we have to do radians. So what is 0 degrees in radians? That would be 0. What would 30 degrees be in radians? Pi over 6. Okay, so I'm going to do all the pi over 6's here, and I'm going to count by pi over 6. So does everybody see that if I go up by pi over 6 to the red, what would another pi over 6 be? The 60, or 2 pi over 6. But we don't refer to this as 2 pi over 6. We refer to it as the reduced form, which is pi over 3. Okay, so now if I go another pi over 6, I'm now at 90. So I'm at 3 pi over 6. Does everybody see that? And again, that spot is not referred to as 3 pi over 6. It's referred to as pi over 2. Then I travel another pi over 6. I am at 4 pi over 6. Does everybody see that? Again, that spot is not known as 4 pi over 6. It is the reduced form, which is 2 pi over 3. I travel another pi over 6. I'm at the 150 degree mark. That would be 5 pi over 6. Now notice, the pi over 6's that are in reduced form are still on the red where the 30 degree mark was. Notice over here, the pi over 3 on the green is the 2 pi over 3 and the pi over 3 there. Okay? So it's not like the pi over 6's just magically disappear and then reappear. It's because it's in reduced form in the other spots. Okay, so then when I move another pi over 6 from 5 pi over 6, I'm at 6 pi over 6, which reduces to pi. Then if I go another pi over 6, I'm at 7 pi over 6. Then I go, so I'm right here at red. I go another pi over 6, I would be at 8 pi over 6, which again reduces to 4 pi over 3, yes. I travel another pi over 6, I'm at 9 pi over 6, which reduces to 3 pi over 2. I travel another pi over 6, I'm at 10 pi over 6, which reduces to 5 pi over 3. Again, traveling another pi over 6, I'm at 11 pi over 6, which is in reduced form. I travel another pi over 6, I'm at 12 pi over 6, or 2 pi. Does everybody see? So it's not like, again, it's magic, it disappears and reappears. It's because of the reduced form. So now if I start at 0 again, and then this time I'm going to travel 45 degrees, what would that be in radians, 45 degrees? Pi over 4. So if I start at 0 and I travel pi over 4, I'm in that spot. If I travel another pi over 4, I'm in that spot. Where am I at now? 2 pi over 4, which again reduces to pi over 2. I travel another pi over 4. I am now at 3 pi over 4, yes?